Okay, for number 24, we're going to go to the whiteboard to do it. They want to know what values of x would the following infinite series be convergent or divergent. So we'll basically find an interval of convergence, and let's go to the whiteboard and do that. We're going to use the ratio test to do that. So the series, let's write this down. Let me just push this up a little bit, get that out of the way. The series, j squared, and then it's going to be, whoops, I don't mean to do that. It looks like x to the j minus 1. And this is going to be j equals 1 to infinity. And we're going to use the ratio test. So the an, in this case here, is going to be n squared times x to the n minus 1. An plus 1 is going to be n plus 1 squared times x to the n. So let's do the ratio test. The limit as n goes to infinity of an plus 1 over an, and we want that to be less than 1. Let's write this down. Limit n goes to infinity. So I get n plus 1 times x to the n, and these are squared, I'm sorry, I should have said squared, times x n minus 1 less than 1. Okay, let's keep moving. Write this over here a little differently. Let's see, I guess I could write this down. Again, I want to point out what I'm looking at now. I'm looking at just this here. That's always positive. So I'm going to write that without the absolute value symbol on it. And what I see is I see n plus 1 over n quantity squared. Now the x's, they could be negative, by the way, so I'm going to use my absolute value symbol. And what would you get? The absolute value of x less than 1. Okay, let's keep going. Limit n goes to infinity. No, that doesn't look like infinity, does it? Let's get that erased. Actually, it doesn't even look like a limit. Limit x goes to infinity. This will be 1 plus 1 over n squared, absolute value of x, less than 1. So I can evaluate the limit now. What do I get? The absolute value of x is less than 1, which means x is between 1 and minus 1. Now, they want to know the interval. By the way, this is an interval, but I don't know if I should include 1, and I don't know if I should include minus 1. So what I need to do is go back to the original series and plug those values in and see what I see, all right? So let's say x equals 1. What's the series going to look like? Let's write this over here. It's going to be this over here. J equals 1 to infinity, j squared, right? If the x is 1, that's what's going to equal. Clearly divergent. Again, if you write the terms out, you have 1 squared, 2 squared, 3 squared. It gets bigger and bigger. All right, let's do x equals minus 1. And what would that give you? Well, let's write that down. That would give you j equals 1 to infinity. You still get the j squared, but now you get minus 1 to the j minus 1, which again is clearly divergent. So the interval of convergence is this over here. If you want to write down an interval notation, it'd be minus 1 to 1. All right, either answer is fine. Right, and the work is fine too. All right, so it converges there, it diverges everywhere else. And that's about it. Thank you.